Hello, good morning, good afternoon, as appropriate. We're just starting now, waiting for a few more people to come. We're at about 19 of, I'm told, 38 people. My name's Alistair Kent. I'm the Tailings Working Group Coordinator with the CIM's Environmental and Social Responsibility Society. And one of our objectives is to provide information, up-to-date information on what's going on in the tailings space to a wide CIM audience. So just please stand by a little longer, and we'll wait for a few more people to join us. Up to 20. I think we'll wait till that hits 25, and then off we'll go. I hope everybody can see a screen now that says technology transformation in tailings support best-in-class risk management, or to support. And a picture of what looks like a well-constructed dam.
Yes, that is a photo of our Mirim Dam at our Salobo mine site in Brazil.
Well, I'm not seeing much movement here, so I think we'll begin.
All right.
Once again, I'd like to welcome everybody to this CIM Environmental and Social Responsibility Society webinar with a focus on tailings. This is one of a series of webinars that the Tailings Working Group that I co-lead is organizing during the year. So welcome. I'd like to introduce our speakers. They're going to present results of a comprehensive review of methods to improve safety in tailing storage facilities around the world with a focus on base metals. The scope of the project covers areas such as characterization, displacement measurement, erosion, water management, hazard monitoring, systems and modeling, and alternatives for disposal. Projects now being deployed and site teams are being actively engaged to explore their needs and requirements and opportunities arising from the application of these new discovered technologies. And the intent, as we'll hear, is to develop site-specific technical roadmaps. We'll hear about ongoing challenges in implementing. So I'd like to introduce the two speakers. First of all, Luciano Oliveira, who's a Senior Principal Innovation Practice for Stratalus Consulting. Mr. Oliveira is based in Arizona, holds an MBA from University of California and a bachelor's degree in mechanical engineering from the Instituto Tecnológico Aeronáutica, and is a certified Six Sigma Green Belt and sponsor. He's worked extensively with large global mining companies, defining new technologies to monitor and manage the risk associated with tailings dams. He supports his clients in driving results primarily through strategies leveraging innovative technology. And besides mining clients, he has advised leaders across multiple industries, including companies such as Honeywell and BASF. He has extensive management experience with these leading global companies. He's worked extensively in digital transformation, topics such as big data, analytics, blockchain, and electrification. His focus is identifying the opportunities and driving the transformation in uncharted and ambiguous spaces where unique capabilities combined with leading edge technology can create competitive advantage. Greg Puro is Luciano's client and is currently the lead of the dam safety group for Vale's base metal operations globally. He's a geotechnical engineer by training and has spent 25 years involved in design, construction, and operation of dams and tailings storage facilities in numerous countries around the world. The Dam Safety Group within Vale acts as an internal consultancy and provides technical guidance, technical assurance, and develops standards and oversees the operation of some 365 dams around the world. So welcome our speakers. Over to you, Luciano and Greg. Thank you.
Thank you very much, Alistair. Appreciate the invitation to speak, and thank you to all the folks. Good evening and good morning to all the folks who have joined us for today. So as Alistair mentioned, today's session, we really want to talk a little bit about the technology transformation in tailings that will help Vale support best-in-class risk management. And this is an initiative that Vale and Stratalus undertook together and have been working on for about a year and a half. Next slide, Luciano. So we have several objectives for today where we're going to go over Vale's geotechnical mission and strategy, talk a little bit about just a high-level overview of the base metals as an introduction to understand the scope of applicability for this initiative. And we're going to talk in a fair amount of detail about the tailings technology program, the approach that was taken, and the outcomes that were achieved throughout the course of this initiative. And then, of course, we'll close out with some discussion on some of the lessons learned and path forward for the completion of this important initiative on behalf of Vale. So I want to start off with just educating folks on what Vale's geotechnical mission is. And really, this is a mission statement that we've been honing and driving through to improve our dam safety culture. And really, the goal is for Vale to be a global leader in tailings management through the efficient deployment of monitoring technology and governance techniques that are aligned with the best available technology and best applicable practices to ensure safety and reduce risk for all of our stakeholders. So the Tailings Technology Program is but one aspect of really getting to be a global leader in tailings management. So the purpose of the Tailings Technology Program is to achieve some specific strategic imperatives. So deployment of the best available technology, but not for the sake of the technological deployment itself, but rather to further achievement of the goal of becoming a global leader in tailings management. The deployment of the best available technology will help us manage our sites in a more safe and sustainable manner, ultimately supporting us in our goal of becoming a global standard bearer in terms of tailings management. One of the outcomes of this will be to improve our social license to operate and result in a risk reduction at a portfolio level for all of Vale. There's a number of risk drivers which were considered throughout this initiative and that we'll be talking about at various different times across the course of the day. There are both direct and indirect risk drivers that were impacted. On the direct side, obviously there are impacts to the bottom line of cost, to health and safety of our employees, and environmental performance of our tailings storage facilities, as well as indirect costs of having material unwanted events associated with our containment structures, the reputational risks associated with performance, and business interruption risks that could result of a downgrading event. Just a high level of our base metals operations. So Vale Base Metals comprises our nickel and copper operations and cobalt operations, as well as some PGMs around the globe. The bulk of our operations are located in Canada, with significant operations in Thompson, Manitoba, as well as the hub of what used to be Inco and is now Vale Base Metals, which is in Sudbury. We've also got operations, active mining operations and refining operations in Newfoundland, Labrador in Canada. As well, we have a number of sites in nickel and copper sites located in Brazil, a site in Chile, and then we have a number of refineries as well as a fully integrated mining complex in Indonesia. So we're fairly well positioned globally in terms of our nickel and copper operations, not just focused in Canada. We comprise about 20% of Vale's entire portfolio, the remaining almost 80% being comprised of our ferrous operations in Brazil. So this initiative covered a complex portfolio of both active and inactive sites, including tailings, water management, residue sedimentation, and hydro dams. So I'm, over the course of the day, probably going to default to just calling them tailings dams, but in fact, it covered all 360 plus dams in the Vale base metals. Next, please. So the magnitude of the transformation brought a number of organizational challenges. As we worked through this initiative over the past year and a half, what we found is we ended up touching, connecting with, and participating with over 150 plus participants, mostly within Vale, but in fact there were external personnel that were involved as well, across 9 different geographical regions. We comprised cross-functional teams from our digital transformation folks, our information technology folks, our geotechnical and our operational folks, risk management, engineering, and dam safety. And when I talk about some of the engineering personnel involved included both internal Vale representatives and engineering talent, as well as some of our external service providers and engineers of record. We also had to grapple, as multinational companies are aware of, dealing in multiple languages and time zones as we work through Indonesia, Brazil, and Canada.
Thank you, Greg. I'll give a perspective of what the work has entailed. Actually, we have started back in 2020. So the project has gone through multiple phases. But just as an overview, the program is really focused in reducing enterprise risk. And we use technology as a means to achieve that. We started with a technology scan just to understand what is available in the world in terms of potential innovation. We defined a landscape of options that the sites could consider. And when we came to the sites, we actually considered all their needs, documented and undocumented needs in terms of what is already seen as items of action. And we also looked into corporate KPIs, so making sure that the ideas of a technology to be introduced could really bring measurable benefits. As Greg mentioned, it was a very much collaborative work, very deep into operations and very cross-functional in nature. As Greg said, the work also involved externals. So for most of the sites, the EORs had a very active participation. So they actually were present in all the meetings when discussing solutions. So in order to make sure that the solutions were really driving improvement in risk and that they were based on the reality of the sites. This work has been driven within base metals, but one of the things that we also did is to connect across Vale with the ferrous metals group. So we could also start sharing best practices across the company from different sites and different business units. We also looked into other industries. I'm going to mention that in a little bit more detail. But in some areas, I say, well, there is benefits in looking at other industries like defense or oil and gas, where there is more investment in technologies, and then the technologies trickle down to application in mining. The moment that we are right now is we are completing the site and corporate level roadmaps. So we have a good definition of the projects that we want to execute, who the project leaders will be, and what options are under consideration. And we are now moving to a full deployment phase where there is really engineering work being done at the site level to deploy new technologies, install, commission, and validate, and all this good work. So when you look at the story of how it got started, that was really a partnership. I think back when we started, there was still a strong desire to move towards improvement, but not a lot of definitions. So part of the work involved exactly designing this mission and vision statements so that the organization could be clear about objectives and what would be done and how it would be done. We conducted a deep technology scan, looking at hundreds of different startups, established engineering companies, also universities, to understand the best of the best that is available for implementation. In this process, we came across just over 200 innovative technologies with a potential for disrupting tailings management. And we also looked into impacts of this technology in the operations. So what it means in terms of changes in the work to be done and processes. So how it's done. So that was covered in the project. Just talk a little bit about where we looked for new technologies. Really looked across all the potential sources. So you see here a combination of some of the traditional big names in the industry. You also see the universities. So we actually sent a request for information to about 900 researchers around the world. We actually got project submissions from about 400 of them. Vale is actually engaged now in a few of these relationships with groups that are working on innovation and development projects. You also see here names that are non-traditional, so entities that are developing things for the military, like a DARPA, or construction, or oil and gas, like a Schlumberger. So we try to look at not only for technologies that are available today, but also in the long run. So what would be available 5-10 years from now, and Vale might keep an eye on these things in order to stay on top of the best technologies. So this is a view of the technologies we found. And the way we grouped the technologies is by application area. So what you see here is a taxonomy that we created in the context of the project to classify the problems into different areas. This proved very helpful because one of the problems is really to make sense of this very complex environment. Tailings practitioners, they are bombarded every day with dozens and sometimes hundreds of different offerings, and just to make sense of what this technology does and what problems it solves. If you don't have a construct like this taxonomy, it can be a really daunting task. We also identified options that are available today. So 0 to 1 years versus things that still require proof of concept or some validation, especially things that are being used commercially in other industries, but not so much in tailings. That requires a little bit of work. And then finally, some science projects, things that are mostly not commercially available yet, but seem to be quite promising. When we got into our second phase, the focus was more into applying the technologies. So we designed things like corporate and site level roadmaps. So that means specific projects aligned with those problem areas that we defined for the technologies, with site owners, with a horizon of implementation and real detailed plans behind them, involving also cross-functional work, budget assumptions, and so on. We defined a vision of the future. So what is the end state that we're aiming at every specific location? That includes combining technologies over time. We also linked the projects to specific KPIs and project owners, so there is accountability for the execution. And we tied this ground level work to a mission and a strategy, so we know at the portfolio level what are the changes that we're performing. One thing that's important to mention is the phase 2 of the work was very much needs-based. So we really took a step back and said, well, let's look at the dam safety reports. Let's look at the review board reports for every site and say, what is the engineers of record saying? What are the concerns in the different structures? And at the structure level, we defined the needs, and that drove the work. When you consolidated across sites and across the structures, there were a lot of common needs. So this is a view of some of the most common items that we came across, and we are going to talk about that later in this presentation. Well, I would like to pass back to Greg so he can talk about what was this process of working with the organization and the sites.
Thanks, Luciano. So yeah, just to talk a little bit about the process overview on the roadmap development. So the review was performed with the sites. So we undertook a series of workshops and really with the sites, we wanted to assign the ownership, timing, and requirements for the projects that were needed and selected with site leadership. So this is not something that was a corporate initiative that we're going to come down from on high and impose on the sites. This was really a grassroots type of project where we started with the needs and pain points at the sites to make sure that we weren't deploying technology for the sake of buying the latest widget, but rather linking it back to a definable business KPI. So we really put the onus on the site owners and the operators to declare whether or not a project was a specific go or no. So I talked a little bit about mapping to needs. So what we did was we started off with needs assessments of the sites and then went back and looked at the various technologies that were identified and found to be available, not just within the mining industry, but without, so that we were mapping solutions to specific needs at the site. And because each dam is unique, it's necessary that each technology roadmap is unique for each site. There are some commonalities, so especially on things like digital modeling of sites and data management, but in many cases, there are unique aspects for each technology roadmap. We looked at a combination of both proven and emerging technologies. So from a technology readiness level of 1 to 10, 10 being commercially available, proven, and already in use in the mining industry. And a 1 being, it's purely conceptual and theoretical work. No proof of concept work has been done, and it may not be ready to be commercially deployed for up to 5 years. So we mapped out different potential technology solutions over multiple time horizons. We also took a portfolio view of piloting. So while many sites are implementing similar solutions in somewhat similar timeframes, there are opportunities for joint approaches to vendors or trials that can be facilitated by corporate teams so that we can do proof of concept work where the technologies are emerging and reduce the risk and spread the liabilities around a number of sites and operations by having the learnings on small trial sites and then expanding the successes to be inclusive of sites where it makes sense. And really, at the end of the day, this is about the beginning of a journey. So there will be further investigations that will focus on potential technology solutions, as well as the identification of the most appropriate vendors. So this is the beginning of a technology journey for Vale, which we expect to be essentially like a continuous improvement initiative, where you're never fully complete because you're always looking at the next technologies that are available. So I mentioned that we did a series of workshops, and really what we did was workshops on a region by region basis. So for each region, we started with workshop 1, where we worked with the site engineering and operations and technical folks, as well as the engineers of record and our consultants, and identified site-specific needs after analyzing reports and assessments that were done, including, review board reports, DSIs, OMS manuals, and all of those typical documents that owner-operators have, which would document challenges and specific needs that are unique characteristics to each site. We then followed that up with a second workshop where we identified commonalities and looked for similar solution sets and created what we called opportunity clusters. So for example, seepage and water flows that related in different structures were clustered into the seepage cluster. So we mapped these opportunity clusters to our identified solutions and then grouped them into a taxonomy of vectors or categories that we created specifically for this project. Then in the last workshop for each of the sites, so as you can imagine, this was a fairly thorough and exhaustive process, but I think it helped to build a really robust solution. We used the heat maps and the performance parameters that we did coming out of the technology assessment, and we narrowed down to prioritize solutions for each opportunity cluster, and then the clusters were chosen by the site owners to become projects for the final site technology roadmap.
Very good. So just an overview of the different types of needs that we identified across the different sites. Some of the needs were quite repeatable. So for instance, I would say in the area of erosion and water management, things like seepage were very prevalent. Also the need to control water quality at discharge and understanding water balance through water models was also very important. A lot of interest in bathymetry, so to optimize the life of the TSF, so understanding tailings deposition, how much capacity to have. Was a lot of interest on that. Displacement, so there's actually a lot of very innovative technologies here in terms of using satellites and drones and LiDAR to understand displacement, and also fiber optics and other things. And finally, there was a large number of miscellaneous things that were unique to some sites. Some of them very interesting, like for instance, the use of booms to catch debris that may cause problems in the drainage systems, or the use of eDNA to understand spawning seasons for fish in certain habitats. That was quite interesting. From this level, there was even a deeper level of needs. So just to give you an idea of how detailed the needs were, for instance, compaction, investigating beach compaction was a very interesting area. We actually found some automation technologies to do this work at scale. Geotechnical stability, of course, was a very good one. For instance, understanding brittle behavior of tailings. We actually looked into some geochemistry approaches to understanding that. And actually, if you go in each of these areas, there's actually a lot of richness into how deep the discussions were. Oh, this was a very interesting one. So checking for liner integrity in the water retention ponds. Very interesting problem. So in certain areas of Canada, we have wild animals intruding, like bears and moose. So the solutions that we looked into include things like, well, placing cameras so we can know if animals are getting there, but also investigating electrical resistivity sensors that can detect water that might be leaking from the liners. So we could definitely spend like a whole week just talking about these different items, but I just wanted to give a sample and an idea of the depth of the work that we went through. So Greg, back to you. Maybe we can talk about the benefits.
Yeah, one of the things that and I think this was a key portion of the undertaking was that we undertook an evaluation with the site on how it lowers enterprise risks, and the way we define risk to the enterprise with respect to tailings and dam performance was a series of risk dimensions. So we looked at cost, business interruption, reputational risk, personal health and safety to employees, material unwanted events. So, that would be comprised of your major dam failures, whether it be a release or a catastrophic failure of a structure, and environmental impacts of performance. So we actually estimated the KPI improvements that would be achieved if the projects were to be successful, in order to allow us to do a portfolio balancing exercise should there be a need to prioritize or rank projects, given constraints, whether they be financial or human resource, our ability to execute all of those projects. And then we built those into a map. And what you see here is a heat map, and the size of the boxes are quite significant. So this is complex by design, but you can see the major risks around the outside in the black text with cost, business interruption, reputation, etc. And within each cluster of risks, there's a number of projects that were identified to help reduce those clusters. And the size of the boxes for each project reflects the size of the business impact associated with that risk dimension, as well as the number of times or the frequency with which that particular project came up at a number of sites. So I mentioned we used 8 geographic regions. If 3 of 8 geographic regions looked at project 2 to reduce the risk of business interruption, that box would be bigger than a project that was only flagged by 1 site during the needs assessment. So this really allows us to take an enterprise risk reduction view of the entire portfolio of projects, because we identified and committed to some 90 plus projects over the next 5-year time horizon in geographic regions. And then this is an example of a typical example of one of our technology roadmaps. So we actually created 9 of these technology roadmaps, and there's all sorts of information on here, but generally speaking, they're broken down by the 6 opportunity clusters on the left-hand column, and then mapped out along a time horizon from year 1 to year 6 across the top. The site owner is identified as the site owner or dam owner for that particular facility, but the corporate dam safety group within Vale is going to be the keeper and the facilitator of managing these technology roadmaps. And then down the list, you can see, located in space and time, the series of projects, who the project owner is, whether that be a site engineer or a site technician. It could be a surveyor, it could be a corporate representative of the dam safety group, or it could be a consultant or one of our information technology business partners, depending on what the nature of that specific project is. project has been located in space and time based on the needs and the criticality at each particular site, as well as taking into account other factors like budgeting and funding and availability of resources or engineering talent to actually execute these projects. So there's a number of factors that went into building these unique roadmaps. So I mentioned we did 8 geographic regions. So there's a unique, distinct technology roadmap for each one of those regions, as well as one overarching corporate one that covers the initiatives that span multiple sites where they need to be done at the business or corporate level as opposed to the site level.
Right. Well, one of the important implications of finding this project was the following. We came to the realization that the way the technologies will evolve in the sites is actually quite complementary. So instead of individual technologies, these technologies will actually become something that we call suites. So for instance, for water modeling, usually you combine all these different elements. So you have sensors, so things like snowpacks, laser flow meters. You need to bring this data to consolidated databases. So you need data integration, you need analysis software. Some cases you also need services like hydrological consulting, weather forecasting, and the combination of all these efforts will give you the ability to manage and model water in the best way. Some of these actions are driven by different parts of the internal value organization. So the digital team, the geotechnical team, the site team, of course, the IT team. So the work was by nature very collaborative. Another interesting point to mention is the types of technology that were common across sites. So a lot of digital technologies. So this is the digital part. There's another page where I talk about other technologies. But just to highlight a few, so there is a great interest in monitoring dashboards. So these are systems where you can see multiple sensor inputs at the same time. So it saves a lot of time. A lot of this instrumentation are becoming automated. So instead of going into the field and collecting the data, you can just get all the data automatically collected in a dashboard. Also, the ability to perform collapse detection. So it's actually a regulation requirement in Brazil, but it's also something that is driving interest in a number of other locations. Modeling solutions, I think there was also a lot of interest. So geotechnical analysis is really evolving to digital twin concept. So the models are becoming more and more detailed and better in their ability to simulate different scenarios. A lot of interest in photogrammetry. So this is the analysis of image collected by drones or image collected by satellites using INSAR. And that gives a lot of insights in terms of what is moving on the site and also water emergence. So that's another thing that you can check by having this type of analysis. Especially for older sites, a lot of interest in automating the way they file and retrieve information. So things like a document management, the ability to overlay information, and the ability to well, integrate data in different ways. And here's a sample of types of vendors that we looked into.
Yeah, I think that's maybe if we can jump in for a second, Luciano, just to elaborate on that. I think it's important to note that we were supplier agnostic in terms of who or where these technologies were available. As we worked through the initiative, we identified numerous suppliers for each of the technologies, but it was really about identifying the technology solution, not the supplier solutions. And I think that's an important note to reinforce, given the fact that most owner operators have various procurement norms in place, which which tend to discourage things like single sourcing to specific suppliers and things of that nature. So we tried to fashion the work in such a way that it was about the technologies and give a suite or a menu of service providers in that specific area.
Right. And well, here are the geotechnical common needs that we identified across different sites. A lot of interest in identifying and managing and controlling seepage. Also displacement and topography surveys. Bathymetry, concrete inspection, that was also very interesting. Vale has a number of hydro assets that have concrete walls and barriers. So automated ways to inspect concrete was a big one. Water quality, so things like measuring for pH, metal concentrations. Also a lot of interest across sites. Weather forecasting, especially when it comes to precipitation and snowfall. Different types of hazards monitoring. So here, a lot of things that are done today just by walking around the site can be to some extent automated with drones and satellites, especially in the harsh winter conditions. If you can avoid sending people to these hazard conditions, there's definitely a health and safety gain to be obtained here. And finally, interest in understanding the stratigraphy of the sites. So this allows models and the geotechnical analysis to be more accurate. So a lot of interest in better understanding the sites. Okay, so back to you, Greg.
So when we undertook this exercise of identifying the technologies, we really had to start thinking about how do we see the future changing in terms of operating and surveilling tailing storage facilities and operational dams. And one of the things we're realizing the significance of the task is that as we deploy new technologies that are going to automate work, it actually changes the focus of the team and the requirements and the skill sets of your teams. So it's going to drive more collaboration and really result in the ability to make more data-driven decision making, because a lot of these technologies are very much about collecting more robust data in closer to real time to allow us to make better analytical decisions and better assessments of current performance and identification of any anomalous conditions. And really what this is going to result in is we're going to take a look at how we do it, and looking at our processes to make sure that they're integrated, multidisciplinary. It's not the same historical version of having the crusty old dam engineer walking the dam in a leathery pair of work boots, kicking stones and making judgments based on what he sees with his eyes, but really about having multi-talented and multi-skilled, multidisciplinary engineering and technical personnel making data-driven decisions. Can you go back, Luciano? Like just and there, yeah. So what it's really going to be about is having connected, intelligent, and always on integrated monitoring systems and new technologies and models which will improve dam knowledge and safety. So it's about getting better information, a single version of the truth, into the hands of the decision makers that are qualified to make high quality decisions and as close to real time as possible. So we're going to need to work in new ways to support this vision. So, having some definite technical difficulties. Sorry for that. So, you know, we need to take a look at what we will do and how we will do it. And what this has really resulted in is Vale taking stock of how we're going to deliver our engineering and dam monitoring and operating services to make sure that we're deploying best-in-class technology and using that improved knowledge to reduce risk to the enterprise. So we'll be looking at higher value-added activities, less boot on the ground and more deployment of technology to do some of the more mundane data gathering that will support the data-driven decision-making. It'll involve new technologies from any number of industries, which will allow us to have more integrated, robust processes that will support our multidisciplinary problem solving. So we're going to need to have redefined roles and governance models to make sure that the information that we're getting that needs to be understood by the operators and maintainers of these structures really understand from a RACI perspective what their roles and responsibilities are to make sure that the new version of the truth and the data gathering that's happening is in fact being deployed and analyzed in a timely and responsible fashion. So this is going to really drive a fast changing, evolving organization because the skill sets are differing. And what we're seeing is the technical skill sets in the information technology space are becoming more prevalent because we're deploying new technologies and gathering more data faster, more accurately, and want the ability to analyze this data with our geotechnical personnel in a timely fashion. Next slide. And this really encompasses the dam safety vision of the future, and we view this as a journey and we're on as we deploy these technologies, and I've said it a number of times, that this is not about the sake of deploying the latest widget for the sake of being leading edge and having the latest widgets. It's really about a journey to move from horizon 1 to 2 and 3, where we go from, you know, the foundational work, which is about improved knowledge, which is using our advances to collect data more quickly and more accurately to help us better understand the performance of our facilities, which then moves us into horizon 2, which is really a portion in the evolution where we're moving into more advanced decision makings because we're getting multi-parameter sensors and dam characterization through different types of technology surveys, such as electrical resistivity surveys and Greta, and combined with machine learning to look at building. Luciano talked a little bit about digital twins for dams. It's really about being able to digitally model and replicate the performance and predict performance of our structures. And then that moves us inevitably down the path towards integrated monitoring, where we're using artificial intelligence that enables advanced stochastic modeling and stratigraphic analysis that makes surveillance, reporting, and alerting technically feasible, right? So a lot more focus from an engineering standpoint on scenario planning and monitoring those facilities.
All right. So just to give a little bit of flavor on the work that is ongoing right now, we have different types of projects that are marching into execution. That includes IT and enabling projects, a lot of focus on infrastructure, connectivity, data integration, automating a little bit of the data collection process. There's a lot of software deployment as well. A lot of these analytical packages require new software. There's work related to modeling and monitoring. So monitoring includes the creation of these dashboards, integrating information for decision making. A lot of these technologies are quite new, so there's a fair amount of trials being planned. Also, new vendors and new approaches that are not fully proven within Vale's environment. And of course, best practice sharing. So once you learn about the performance of a certain technology or vendor, we are disseminating that through the organization. So there is a very quick learning curve on what we do. That's requiring us to have a very intense cross-functional collaboration. So we are working on racing models so everybody understands what their role is in the program, especially because we have just over 100 people who are very directly involved in this program. And well, finally thinking about lessons learned, we had some challenges, and we also had some specific solutions. So thinking about companies that may be embarking in this process and thinking about doing a similar program. So first challenge is there is multiple internal stakeholders, different priorities, different value drivers. So we just need to recognize the complexity going in and have ways to engage everybody. Also, there are no silver bullets. There's no hope of a corporate solutions that can be replicated across the board. So every site is really unique. So starting with the site needs is really what we recommend. It takes a lot of time, a lot of workshops, like Greg mentioned, but that's the right way to do it. There's definitely risk aversion. So there is the word of innovation and the word of engineering. The word of engineering says, well, we want things that work for sure. And the innovation says, well, we want to push the envelope on performance. So there's definitely a conflict that we need to mediate and think about. So how to bring the reliability aspect before you think about escalating the solution in a large portfolio. And also, a lot of these new technologies require investment, and the benefit is health and safety, is risk reduction. So these are things that are very difficult to quantify in traditional NPV models. So that's also a challenge. So some of the approaches we used were a program management with a clear linkage to strategy. So everybody knew why we're doing that and what the objective was. We were lucky enough to count with Greg and the senior sponsors within Valley to steer the program. So having a governance approach is also something that is very important. Being grounded on reality and needs, I think that was another approach that proved to be very much valuable. So we can link the current state to the future state and how we're going to get there. And finally, engage the sites and engage in different teams and operations. So the people that are really involved in the day-to-day and for whom the transformation will bring the most impact. And doing that ground up, I think that was another solution that worked quite well.
Yeah, if I might, Luciano, I just want to talk a little bit about the second challenge, talk about the scalability of solutions. So one of the most interesting learnings that I personally experienced coming out of this was that push and pull between the sites which want customized solutions to help address their needs versus the overarching traditional corporate desire to have standardized systems and processes to keep costs, whether it be project management costs, operational or licensing costs in the case of software, and maintenance costs on an ongoing basis to keep those more manageable. But because each dam essentially is unique like a fingerprint or a snowflake, it's not always appropriate to have the ultimate outcome be scalable solutions. It's certainly a goal which needs to be considered, but it's not always a possibility.
Right. And I think this is your slide, Greg, just the path forward and what we're doing.
Yeah, so just want to talk a little bit, and then we'll open things up to questions. But this is really, one of the open challenges as we're starting to wrap up this initiative and finalize the technology roadmaps in the coming days. How are we going to make decisions, and how is the portfolio going to be managed as a business? Because these technology roadmaps are extremely valuable in terms of shaping and coordinating our efforts and gaining alignment amongst the management team. But you can imagine over a period of months and within a couple of years, it's like any long-term plan. The farther out you go in space and time, the less accurate your predictions are going to be. So, projects are going to be accomplished, projects are going to succeed, projects are going to fail or be canceled. And that's a necessary realization in the world of doing basically research and development work on deploying new technologies and tailings. And new needs are going to arise at the sites, which are going to result in the need for newer technology. So how do you update the technology roadmaps and maintain the program momentum that has been built over the past year with the sites? Then we need to also consider, as we deploy some of these new solutions within Vale's current operating environment, as these proof of concept trials are executed and we successfully deploy, in some cases, these technologies, how do we then standardize or integrate that work into the way we do business so that it becomes a robust, sustainable solution to challenges we face at some or all of our sites? In the case of Vale being a multinational company, there's a lot of talk and consideration being given to how do we coordinate efforts for multiple teams and multiple geographies. As we look at having our first line of defense in our operational personnel, we've got dam safety groups and in the corporate Vale base metals world. We've also got a corporate geotechnical directorate in the Vale world that spans ferrous and base metals. So we've got multiple stakeholders, and we need to make sure that we don't duplicate efforts and there's no gaps between efforts in each of these groups. And then there's also the work that we need to look at from a partnership perspective of how do we move from where we're at today with a shortlisted set of vendors or potential vendors to a certified solution that's been successfully deployed at one of our sites to address a risk. And of course, I talked about the governance and really, which comes down to the program management. What are we going to focus on and what are the priorities? So this is where I think the work of tying back to business KPIs and business risk drivers is really going to give us a lot of traction in terms of the program management at a portfolio level, which will allow us to meet the business priorities and spend our finite resources, whether they be human or financial, in the most responsible manner.
Right. Well, with that,
So
I think we can move to Q&A.
Yeah, so that covers the bulk of our presentation. We appreciate Luciano and I have been doing a lot of speaking for the last hour, so we'd like to open things up to the audience. Are there any questions or comments on anything that we've covered over the past hour?
Well, I see 4 questions. I don't know whether Greg and Luciano, you can see those. If you cannot, then I will read them out.
Yeah,
And,
please do. I can't see them.
I do encourage everyone to use the question box. It's open to everybody. I'm given to understand that you should be able to see all of the questions, but I'm going to start with the first one posed, and we'll get to it. First off, then, can you share the 200 technologies that you've covered? Is there an intent to share that listing in some fashion?
Well, it's actually in this presentation. It's in that slide where we have a radar and the 3 horizons. So it's actually here.
Yeah, I mean, the intent of the presentation was not to share the specific technologies, but more an overview of the process. But the technologies that we identified, a lot of the research work that was done, and Luciano, correct me if I'm wrong, but it was really around contacting, whether it was an academic institution or a supplier or a service provider, for the purposes of looking for these commercially available technologies. So, it's not nothing proprietary or intellectual property of Vale. As Luciano said, if you blow up this slide, all of the technologies are described in this radar graphic.
Okay, thank you. And the next question, I'm trying to do this in order. Let's see. There's lots of them coming in now. Okay. I'll just read it out because I don't fully understand. Excellent dam safety and reduced hazards. What about dam use in the future? And I presume that means the evolution of dam design. Is that part of this?
Yeah, it was from a limited perspective, looking at things like digital twins to being able to analyze and predict current and future performance of a structure. If that question is more related to looking at long-term closure options, we did not specifically look at landform and closure types of technologies. The focus of this initiative was on monitoring, surveillance, and operational assessments of tailings dams.
Okay.
Yeah, well, but we actually looked into some techniques of alternative disposal. So actually, some sites consider options to traditional tailings storage as a way to extending the life of the assets. So we will briefly touch those options, but I would say, like in every program that goes into implementation, there's a lot more focus on the short-term things that are really related to monitoring and risk management, as Greg mentioned.
Okay, good, thank you. Do CEOs and financial personnel understand that each site is different? The people signing checks assume each site is the same and often dictate the technology because it worked elsewhere. How about that?
Yeah, I think that's definitely an internal challenge, and I suspect that's not unique to Vale, but rather a challenge that's faced by most, if not all, owner-operators, as often some of the senior decision makers in an organization are not necessarily geotechnical engineers or dam practitioners. So what it means is, we really did spend a lot of time internally within Vale talking about describing the process of how we develop these needs-based assessments, because it's important for the folks that control the purse strings to understand that the geotechnical engineers understand their structures and need to continue to understand their structures better. So the tools and the methods that we use to improve and advance that knowledge base need to be customized to the structure we're looking at. We operate in different climates. Some of our regions are tropical or subtropical. Some are in northern or in permafrost environments. So, the necessary technology solutions that are needed to address the issues we face need to be customized, scaled up where appropriate, but often that's not traditional. So explaining that to the CEOs and CFOs of companies can be a challenge, but you need to, in my experience, you need to be very explicit about explaining the process that was undertaken to make sure that the technologies are the right technology suited to the issues of the site.
Yeah, well, just to illustrate what Greg said, you have some closed sites in remote locations where if you need to make an inspection, you have to fly people in and fly people out. So the cost of the inspection is quite high. So of course, in this situation, there's a lot more interest in using satellites in remote inspection techniques, as opposed to if you are in an operating site where you have people regularly walking around the site. There's a lot less value and a lot less interest in remote monitoring.
Yeah.
So every site is really different. The way it's operated, the way it was designed and constructed, and the geotechnical conditions. So what type of soil and materials you have in these structures.
So the other thing I think, that speaks, it speaks to the value of having the multidisciplinary approach that we employed to identify these solutions, so that when you go to these senior folks in the company to say we need to justify a budget of X dollars at each particular site, and this is why we need them, we can say, look, we've investigated scalability, we've involved the geotechnical personnel, we've involved the engineers of record, we've involved IT and our technical, our digital transformation folks, to make sure that we're all aligned that the solutions we have identified are the best solutions for that particular challenge.
Sounds like fun.
Yeah.
Okay, next one. Can you comment on how traditional value assessments overcome the inherent limitations of net present value decision making?
Luciano, can you take that one?
Yeah, well, I wish I could say there is not NPV, but there's this other three-letter acronym that replaces it. I don't think that's the case yet. So Greg mentioned that we made a map of different key performance indicators that we intend to improve. So things like health and safety, mitigating the risk of unwanted events. We have like operational costs. A lot of these metrics point to a benefit, and we have a semi-quantitative way of describing that. So we have actually scores that say how big of an impact you expect to have, but we don't have a way to quantify that in dollar value just yet. So what we do is to create support for the program with the key stakeholders, so they know that things are moving in a certain direction and impacting certain indicators in a certain way. But they need to have trust and believe in the process and understand what is being done, and be supportive of the idea that not all things can be quantified in a traditional NPV analysis.
One thought that comes to my mind that I've tried it on a project recently is to do a multiple accounts assessment. So you score the benefits relatively of alternatives and plot that against cost, and that can be quite instructive as to where you get lots of bang for your buck versus where the benefits of increasing costs diminish.
Yeah, that's becoming much more common in the practice and the profession, especially when you start looking at things like closure costs. As you project out, 50, 75, 100 years, the net present value of the activities that you're going to undertake at that point in time approaches zero. So, you tend to make your decisions not looking through the right financial lens.
Okay, let's find a couple more questions for you. Just have to scroll down. How do you convince financial persons that tailings management is important and requires technological advance? You may have answered that already, I think. It sounded like it was with many arguments that are very well structured and comprehensive and drive the point of uniqueness of a situation to them.
Well, agreed. And in addition to that, I think, it's important in the current context of the mining industry on the heels of some of the most recent failures in Brumadinho and Samarco, Cadia, Mount Poly, that awareness at the highest levels of our organizations is really starting to take root and take shape. And that gets further enhanced by things like the new global tailings standard from ICMM that was issued last August. So it's becoming easier to gain awareness at the senior levels of the risks associated, and the fact that these are enterprise level risks. These aren't trip, slip, and fall hazards. these are enterprise level risks that we're trying to manage, and they deserve the appropriate level of care and attention as a result.
Yeah, I think these new global standards were co-convened with the participation of representatives from the investor side. So there's a clear understanding that an unmitigated risk can lead to catastrophic situations that have a very direct impact in market cap. So for that reason, I think the Vale leadership is very much on board in supporting global standards and, as Greg said, not only following but being a leader. So I think that's the aspiration and the ambition of this program.
Well, and additionally, I think societal expectations are also becoming increasingly more stringent with respect to risk management on major facilities like tailings and water dams. So, societal expectations are increasing, financial stakeholder expectations are increasing. There's certainly heightened awareness at the most senior levels of companies, and the industry is heading in the right direction as we implement things like the global tailings standard. So technology is one more lever that we can pull to help advance the state of practice.
Okay, thank you. This may also be a bit of a repetition. First of all, thanks for a great presentation. This comment, could we have an insight on the non-traditional value assessment to overcome negative NPV challenge for the sustainability projects? I think you answered that, but if you have more to say on that.
Yeah, no, I think that's related to what I mentioned in terms of the different KPIs that we developed this scoring system, so where we can link the projects to benefits in different areas, and then of course we can use these benefits to prioritize projects. So understand to some extent bang for the buck. So that's our way to assign value to projects in lieu of a regular NPV analysis.
Okay, thank you. What are the missing gaps in terms of available technologies that need new companies to be formed to commercialize?
Well,
I think,
that's. Yeah,
sorry, go ahead. I was going to say, one of the biggest opportunities and technical challenges that we commonly see is the characterization of the groundwater, not just levels, but more specifically the movement of groundwater through a structure. So not only where is the phreatic surface, but what is impacting the phreatic surface? What are the flows? What are the flux rates through your dams, especially if you have earthfill embankments that are designed to seep, as all dams seep to some extent. But it's measuring, as I said, not just the phreatic surface, but the location of seeps, the flux through those seeps, and how your dam is actually performing. Are they indicators of internal erosion? Are they indicators of filtering compatibility, or whatever the case may be from a failure mode diagnosis perspective?
Yes, I wondered that same question more from a soil mechanics state, the state diagrams that show how close you are to the failure envelope. Are there better ways to really gauge the nature of the condition of the piece of soil that's holding your structure up? And it's quite hard to do that. How do you put strain gauges on a piece of soil and measure pore pressure at the same time and really build a global picture of that mass that's doing its job, you hope?
Yeah, some of the technologies that were identified for measuring things like stress in an in situ condition in, say, the toe of a dam are a little farther out on the technological readiness level, but certainly the technologies are heading to a place where as we get technological evolution, and as our academics and suppliers and inventors create some of these technologies, we're just going to continue to get better and better ability to measure things like in situ brittleness, for example. Start looking for things like creep rupture and some of the contributing factors that resulted in Bruno, for example.
Yeah, I think
Excellent.
there's a ton of opportunities in terms of companies offering more end-to-end solutions and being more of a real long-term partners as opposed to transactional vendors. So, for instance, we showed in this presentation a suite to solve the problems of integrated water management. Today, if you want to have all those pieces together, it's really a piecemeal approach. You have to deal with maybe 10 different vendors. I think in the future, there will be more and more space for companies that bring a lot of the solutions together and make it easier for operators to move into um, a better, a more integrated solution. Another example worth mentioning is also multi-physics analysis. So today, you can go and hire a company to do a CPT survey. But if you want to mix the CPT data with drone data or inclinometer data or other instrumentation that you have, is still quite a cumbersome type of process. So some companies are starting to move in that direction, say, well, we can actually integrate everything and give you a comprehensive analysis of your stability condition, but it's still not quite prevalent. So there's definitely an opportunity for bundling solutions and being more end-to-end.
Next question. What change management methodologies have you been using given the magnitude of the changes required and the large number of people to be brought on board?
Yeah.
Yeah, that's an excellent question because change management is very topical in the context of tailings dams. Um, we tend to use a lot of traditional engineering, design, and constructability reviews by multiple lines of defense. So, deploy the frontline operational and engineering personnel, in addition to the corporate technical oversight bodies, in addition to our independent engineers of records, and again, falling back on methods like independent technical review boards that we deploy at our sites to help to make sure that we're managing risk appropriately, especially the risks associated with changes, which don't want to be undertaken lightly.
Yeah, well, we didn't use a formal change management process, but there are certain elements of our approach that I would recommend to anyone trying to do this type of transformation. So one of those is just stakeholder management. So recognize that you have different voices in the project, and they need to be heard and taken into consideration. So the way we designed our meetings and the way we prepared for the meetings with some one-to-one meetings to engage stakeholders in a low risk type of situation. I think we're very mindful about how to engage and when to engage different people, when to do things in the collective setting versus doing things in a more risk-free environment.
So Luciano, if I might, the management of change processes that we're going to be deploying are going to come during the project management phase of the proof of concept work for these new technologies, not in the technology identification and selection phases. So when we move into doing trials, especially in new and emerging technologies, the appropriate risk assessments need to be undertaken before the work is actually executed to make sure that they're, minimize the likelihood of any unforeseen consequences.
Right. A couple of other things I would mention, Greg, is also a focus on transparency. So just making sure that everybody knew what was going on at all times. So no hidden agendas. So everybody had visibility on our objectives and progress over time. And also considering different audiences for communication. So also being respectful of the time of everybody that was engaged in the program, and that's bringing the contents in a way that was meaningful for everyone.
Okay, just looking for any more questions. Sorry, the system's a bit clunky here. It throws questions just all over the place and not in time sequence. So
Okay.
I apologize if I'm missing anybody. There was a question here: what technologies were on site and what was via drone or satellite monitoring? Because you haven't actually deployed, that may be an answer for the future, for a future update, perhaps. I don't
Yeah.
know.
We have done some, so there were some technology trials ongoing even in advance of this initiative. So it's not as though we just up and decided now that we're going to start from ground zero. So we have done drone deployment technologies, both of autonomous boats as well as autonomous aircraft. We've done the deployment of satellite and radar technologies looking for displacement at different sites and different geographies with varying degrees of success. So each project to deploy a new or evolving technology is an opportunity and a challenge to overcome the issues that present themselves. And as I said before, the companies need to be prepared that not all trials will be successful. There are cases where we've tried to do things at a pilot scale because there were no guarantees that that particular technology was going to work. So we are prepared to accept the fact that in some cases we may not be as successful as we would like.
Yeah, there's really a lot of technologies already being deployed. So fiber, radar systems, different types of sensing devices like shape arrays, vibrating wire piezometers, different types of probes, lot of different type of imaging devices as well, different payloads on drones, so lidar systems, camera systems. So it's a lot of things that are being currently trialed.
Okay, thank you. I don't see any other questions. I had a couple myself, if I might. I wonder what your take is on this myriad of suppliers offering and trying to get into the tailings game. How you view the challenge of sifting through those that overpromise versus those that really have something good to offer you that just hasn't come to our industry yet.
Yeah, I think that's a very interesting question, Alistair. And we encountered that challenge when we started doing some deployment of INSAR technology at a number of our sites. And the approach we took there to try and sift through some of the claims that were made by various service providers, some more incredulous than others in terms of what the technologies can do or would do. At times we've heard various suppliers make claims that they can see through snow or through water or through vegetation. And, it really speaks to the need to doing your homework on how they actually achieve those objectives, because one of the learnings we've got is, it comes back to this comment that there's no one technology that provides a solution to all of your challenges. So in the case of INSAR, for example, it worked well at some of our sites, and then some of our sites it did not work very effectively at all, for a number of different reasons, whether it be the accuracy, due to the wavelengths and the algorithms that were used, or whether it be due to vegetation or climatic conditions. So my advice, if I could give any, would be to really deploy new technologies cautiously and judiciously, because of the expectation that there could be a failure rate. And if you assume your failure rate on technological deployment is going to be, say, 25% on a project or portfolio basis, that means that you want to approach them cautiously when you start looking at expensive technologies, of which I would categorize satellite monitoring in that bucket, although they're rapidly becoming cheaper and more accessible to them.
Yeah, no, I think, Greg, you're absolutely right. It's about doing the homework. So really understanding what the state of the art of each technology is, and what expectations are realistic, and what expectations are not realistic, and understanding that vendors are not all the same, even in the situation where they may share things like INSAR, for instance. They all buy images from the same satellite constellations, but what they do with the data, the techniques they use to classify and select the images, and um, how they do the analysis might be quite different. And some might do well in certain conditions, and some others might struggle in other conditions. So I think having this knowledge before going to bed with the vendors is definitely very important.
Okay. Well, I see looking through the chat and also the questions that many people have appreciated this presentation, and myself included. And I hope that you'll agree to come back sometime in the next year or so and give us the sort of the next update on how you're going. It's fascinating, incredibly relevant to the current situation we all find ourselves in. So once again, I'd like to thank you so much, and let's keep this communication going. And best wishes in your ongoing endeavors, and stay safe. Thank you.
All right. Thank you very much
Thank
for
you
the
very much.
opportunity, and have a good day, all.
Bye,
My
everybody.
pleasure.
Thank you
Cheers.
so much. Bye-bye. How to switch it off. Thanks, guys. I really appreciate it.
Right.
Thank you, Alistair.
See you guys. How do I turn it off?
I think you just exit. That was awesome.
Yeah, wonderful. Good. Well, we'll be in touch, I guess.
Okay.
Take care, Karen. Bye. There we go. Okay. End it for everybody.